company has a policy that will compensate for the loss of revenue due to severe weather. The policy pays 1,000 for each severe weather event in a year after the first two. The number of severe weather events per year is Poisson mean 1. Calculate the expected amount paid to this company in 1 year. So let X be the number of severe weather events in the year. So then X is Poisson. So f of X is equal to mean power X, e power negative m over X factorial, and the mean is given to be 1. So that comes out to be e power negative 1 over X factorial, X equals 0, 1, 2, 3, and so on. And let Y be the payout. We have to find the expected amount for the payout. So the payout happens, doesn't happen for the first two, but it starts happening after the two. So when X is equal to 2, we don't have a payout. So in fact, here we can specify the payout is this. And the payout starts happening from X equals 3 onwards. 3, 4, 5. And we have to find the expected value of the payout, expected amount paid. So expected payout. So E of Y, which means E of 1,000 times X minus 2. The 1,000 can be pulled out. Constant can always be pulled out of the expected value. So 1,000 E of X minus 2, so that's 1,000. And E of X minus 2 means you take the sum of X minus 2 against F of X. And we have that X goes from 3, 4, 5, and so on when you're dealing with the payout. Now, we would like this sum to start at 0 because then we can use the properties of expected value and for the sum of all the values after we break this up. So we want this sum to start at 0 instead of 3. So if we do that, so here in the next step, I've written it the same thing, but I'm starting the sum at 0 instead of 3. So that means that I have added 0, 1, and 2. See, this was starting at 3. It was missing the 0, 1, and the 2. And if I add the 0, 1, and 2, which is what I'm doing here, then I have to subtract it out. So I have to subtract the same thing where the sum goes from 0 up to 2, which means 0, 1, and 2. And now the reason why we did that, as I mentioned earlier, was that once now you break it up, so it'll be 1,000 xfx, and this time this would be negative 2 times 1,000 is negative 2,000, summation of only f of x. And now summation of f of x from 0 to infinity means you are summing all the values of the probability function, and we know that they go they sum to 1, and you know that all the values of the probability function in this case means the values from 0, 1, 2, 3, and so on. That's why we wanted this sum to start at 0, so that we could say that all this sum is 1. And the xfx, you know, is the expected value of x when you consider all the values of x, which is what we are doing. And this when you open up this sum, this means it's when x is equal to 0, this would be negative 2 f of 0, and when x is equal to 1, this would be negative 1, 1 minus 2 is negative 1, so negative 1 f of 1, and when x is equal to 2, this thing becomes 0, so the whole thing becomes 0. And then this simplifies to plus 2,000 f0 plus 1,000 f1. And now E of x is the mean of x, which is given to be 1. Remember, the Poisson variable had the mean 1, and x is that Poisson variable. So E of x is also 1. So E of x is 1 just because of the number given in this problem, that the mean was 1. In general, it doesn't have to be 1, but this summation of fx is always 1, because that's the basic probability law. And then we have f of 0 comes out to be e to the negative 1, and f of 1 also comes out to be e to the negative 1, because this is f of x. And you put x equal to 0, you get e to the negative 1 over 0 factorial. 0 factorial is 1, so you just get e to the negative 1. And when you put x equals to 1, you get e to the negative 1 over 1 factorial, and 1 factorial is also 1. So that's why both of these are e to the negative 1. And all this simplifies to 104. That's choice B.